Hi everyone, this is the first video. We'll be talking about the road intersection design. Before we start talking about the intersection designs, we will go through and we'll review the road design, but this time for urban subdivision or urban development rather than a rural road. So quickly we'll go through the road design, reviewing the steps, what we've done before for standard road design. Having said that, we'll look at the differences with the urban road design rather than a rural road design, where our focus, if you remember, during the rural road design was on the balance between cut and fill, the K values, the radiuses for a horizontal alignment turns, the K value for the vertical profile. We've got slightly different things that we have to consider and focus on during urban subdivision design. So I will start by downloading the file from your Learn page on session 13 or 14, intersection design. You should have that link there. The video I'm just recording will appear just before this video as soon as I finish. So if I'll download the file here, this is an example of what we worked on for the parcel design. And in this example here, I'll be working on the urban road design this time rather than the parcel design or the rural road design. So as you can tell and you can see that I'm working on a separate file to the one I've done for the parcel design. I usually try to keep in two separate files just so I don't stack too much information on top of each other, and usually that will slow down the file or work in progress. So just closing that. I'll be designing the aim. First of all, let me hide the surface here. This is the existing ground surface. So I just have done a few steps for you by importing the points and creating the surface, so you don't have to repeat these steps again. Quickly, what I will do, I'll just hide the surface here, put it on no display, so it doesn't be on the way for work. My plan is, and this is just for the practice side of things, we've got all these yellow lines representing the center line of the proposed roads. Obviously the center line without adding any curves or actual road design. So this is what we'll be doing in this stage. I'll be designing this road here as alignment 1. I'll choose this road to travel from north all the way to south, as well as north to south, as well as I'll design this road with it here. Road, I'll call it alignment 2, again traveling from this point here north to south. I'll start by creating the alignment for these two roads. So I'll just go to alignment creation tool. I'll just choose the naming myself to make sure all the naming the way we want it. Alignment 1. I'm not going to add them to a site for now, and this is a proposed centerline alignment, and I'll choose to show just the major and minor labels for now. As I said, I don't want too much information or too much annotation. We can add them later on, just so we can work. The main focus for this exercise to know the differences between urban road design and rural road design. That's 1, 2, so we can carry on with this file to use it for the intersection design for the exercise after. So I'll be choosing minor and major and minor labels only for these stations, and I'll choose OK. This is one of the main first differences that we will see now. Usually for an alignment on a rural road design, we used to care a lot about the speed limit on that road and then going and calculating our radiuses, if you remember from the equation that we had or from the Ostrides part 3. In this case here, as we discussed it before, in urban road designs or urban roads or suburban areas, put it this way in a clear way, we don't worry too much about the radiuses. Number 1, because initially we're not creating, if you look at the shape of the development here, we're trying to minimize long stretches of roads, as well as we're not creating a comfortable track for cars to speed up. We need to create some motivation for the driver to slow down, put it this way. Okay, so I'm not worried about what's the speed limit and what is the friction and super elevation, all of those. I'll be choosing a radius that would be suitable for that use for suburban areas. So that could be, number one, it depends on the area. If there's any special requirements from the council, for example, I think I had it here somewhere. I was just a few weeks ago working on a subdivision, a new development in an area that has a bushfire risk. So we've got some specification from the council there for the radiuses and for the cul-de-sac sizes, just to make sure a fire truck, so for example, as you can see, different areas may have slightly different conditions or specifications. We've got here, they take in consideration for a fire truck, if the fire truck will use any of these roads to have enough space for turning or doing a U-turn and leaving a closed end or cul-de-sac road, or if there's a T-junction, what would be the radiuses and all of those designs. So I'll be using the 12-meter value here for the center line road. We don't have any, as I said, for each project we have slightly different specification. If we don't have any, which is usually you would, by consulting with the council for that area, they should give you all these details. If we don't have those, if we choose something from 12 meters to 15 meters, that should be suitable. So I'll be choosing a radius for the horizontal alignments of 12 meters, as you can see here. And I'm not worrying about applying the formula and calculating the radius for that. So I'll be choosing that and choosing alignment with tangent with curves. As we agreed, keep the auto snap off, shift right click in point to make sure I'm clicking to the right point, and all the way to here. This is alignment 1 is done. I'll be closing so I can create another alignment, and that will be alignment 2. All the same specification as we agreed. Please keep an eye on the direction. You will see later on the direction is important to us, so we know to create the correct cross sections and components that we will need. So I chose for alignment 1 north, traveling all the way south. I'll choose the same for alignment 2 from north to south. There's no rule about it as long as you know where you started and where you ended. Usually I try to start either north or west, so top or left. Okay, so it's up to you. Now, if we go to again tangent with curves and in point, starting from here, by the way, it's worth mentioning to check that your radius is suitable for that road design. If you find that your radius won't be suitable there, just make sure that you can change the radius there. Okay, so if I found that the radius here wasn't good enough, what I can do, for example, if I found this radius here is not the way I want it, geometry editor, by selecting the alignment, geometry editor, and that will give me the option to open the panorama view for my alignment. And this is the first, this is the second. This here is the second one. We had the first one around here. Anyway, if I select that straight away, that should highlight this for me in red. Okay, so I can, if I want to make it smaller, 10 meters, but I think that would be a bit tight to work with 10 meters, so I'll keep it at 12 meters, just for your information that you can change those. Okay, step number 1 is done, and we talked about the first difference between rural road design and urban road design in terms of horizontal radiuses, horizontal alignment radiuses. Number 2, and the obvious difference between them, is the cross section. We talked about this during our cross section road design, cross section lecture at the time, so we can tell the structure or the components of a cross section of an urban road is different than a rural road. Okay, so we've got the same 2 lanes. It could be wider or narrower, it depends on the requirements again for the specific design that you're working on. Depends on, are you designing a smaller rural road traveling between 2 towns, or are you designing a highway, for example, or are you designing an urban road for the main center of the town, or you're designing just another urban road but for the suburban side of the town in between the houses, you won't see these extra car park spaces on those, and that very wide street landscaping around it, for example. Okay, so we've got variations here. The main difference that we need to know between the two, between the urban road design and the rural road design, we've got main differences. It's obvious differences for the cross section. The rural road design, we talked about 2 lanes, 2 shoulders, verge, and the cut and fill area, what we call it the daylight or the battering area. These are the components, just to remind you. Now, in terms of the urban road design, we've got the 2 lanes. Again, they may vary in width, size, all of those. We may have a car space on both sides, for example, the roads within the city or in the area of the center of a certain town. We will have the curb and gutter rather than having shoulder to provide the end of the road area or the boundaries of the road area. Then usually we have a space for trees to be planted, for landscaping, for road furniture, for example, signs, all of those. That's where usually they've been added on this part of the road. In Civil 3D we call it boulevard. So it's an inner boulevard, and you may have space on the outside called outer boulevard. Okay, you'll see them when we start doing the cross section. And we'll have sidewalk for people to walk. We may have them on both sides of the road, or we may have them just on one side of the road and the other side won't have, for example, would be missing on, for example, this sidewalk there. So it varies from one place to another. Regardless, we will take an example and we can apply differences to different designs. If I go back to our Civil 3D just to show you an example of urban road. So this is from a new subdivision, an area where I have 2 sidewalks on both sides. This is the area where we agreed trees would be planted. If there's any light poles, if there's any signs, would be added in this area. Okay, just outside the curb. So the 2 lanes are confined with 2 curbs, curb and gutter we call them. The upstand part we call it the curb, and this area here where the water will collect will be the gutter. We've got the boulevard, sidewalk, and if there's any landscaping, or that's where the boundaries of the houses will start. So if I just move on to another location, for example here, just to show you. So the sidewalk, not necessarily to be on both sides of the road, could be on one side. If we don't have a sidewalk, definitely we'll have a space there for trees, for signs, for any light poles, for any services to be mounted here on the side of the road. Okay, so I will take a generic example for now just to simplify the work. So I will take this example here that we have 2 sidewalks. We will have a boulevard on the inside, a small boulevard on the outside, similar to what we can see here. If we will do that, I will start actually by drawing the road cross section rather than the profile, which is we can do either or. So to create a road cross section, I'll call it assembly 1 general. Yes, I'll keep that name. That's a good naming. So I'll choose OK. I'll just place that here. I'll have to turn the to space. I don't need it. I'll turn on the tool palette. So if I go to lanes, I'll choose the lane A or R as usual. I'll add the lane. I'll keep an eye on the requirements. So that's a good starting point that, okay, what are we adding to this cross section? So let me just escape from here quickly and go to our, this is what we call it, the road reserve. So this space here, what we have for the road, we call it the road reserve. So this is the road reserve in between the 2 properties, in other words. So let's go back to that. As you can see here, all that space from the boundary of the property all the way to the other property across the road, we call it road reserve. It's the area reserved for that road, as simple as that. So if I measure to start, if I don't have information about the cross section, let's start by measuring how much road reserve we have and what we should be doing for that road reserve. So if I'll go to measure the road reserve, I choose the aligned just somewhere here, nearest on that, and perpendicular to that. So I'll measure there. I've got 15 meters road reserve, 15 meters wide road reserve. That's good to know. We'll need that when we're designing our components here. So let's start with the basics. I added the lane, that's at 3.6. Let's keep it at -3 crossfall as what we've done before. If I'll do that and go back to, you can always come back and change -3, -2. I'm not sure about the other videos when I created the intersection, what was the crossfall on those, but you can easily come back to those, select the lanes and change the crossfall on them. The next component after the road, as we know, that would come straight away, the curb and gutter. As we said, we're not providing a space for the cars. We'll just end the lane here with a curb and gutter. So I'll go to the curb and I'll add a curb and gutter general. Obviously we need it to be mounting at that point there to match the same height of the road. Then we'll go to adding sidewalk. I'm still within the gutter. I'll add a sidewalk. So the sidewalk, I'll need the sidewalk to start from here. And that's where we have the information here for the inside boulevard and the outside boulevard. I'll keep those for now. Actually, let's fix them now. In fact, no, let's keep them now so you can see what issues we may have if we fix them later on and how we fix them. And then the last thing we need, as usual, the daylight. We need that to create the daylight general, to create the targeting, what we call it, to the existing ground. So I'll add that as 6:1. Let's make them 10:1 rather than 6:1. So 10:1 and 10:1. So we can create a gradual transfer between the road or the road area and the surrounding surface. We don't need to make it too steep there. Okay, so this is the case here. As we agreed, I've got 15 meters for the overall width. Currently, if I measure the width I have, so in other words, I have 7.5 for each half of the road. So for each side here, I've got 7.5, which is made of a lane, one lane here, curb and gutter, sidewalks, and whatever we will have, and then the daylight will start. So if I'll measure how much I've got there, so I'll turn on the snap for now. If I measure from here to the end of the components I do have, I have only 5.7. So if I need 7.5, so that would be what, 5.5 to 1.8 I think I'll need. So 7.5 take 5.7, I still need to add 1.8. So if I create this as my cross section, my road will be narrower than the space I have. So that 1.8 meters I'll add on the inside boulevard. I'll add, because we do need an inside boulevard, 1.5 meters there. And on the outside boulevard, I'll add 0.3. That should fix the difference. And that's what I was saying, because I added the daylight to connect to that link here, by adding the 0.3 on the outside, the daylight didn't move with it. So to move the daylight to the end of this sidewalk assembly, or sub-assembly, what we call it, all I need to do is just select here and I'll choose move from here. This move, as you can see from the explanation, I'm keeping the mouse so you can read, it moves the sub-assemblies. I should move from here. I shouldn't go back to the home tab and use the AutoCAD generic move. That's for standard objects, but for sub-assemblies we have specific tools here. All I have to do, just by selecting those tools, that will appear here to choose move, and will ask me where do you want to move it. I'll say move it to this point here. Okay, and as you would know from what we've done before, even if I need to mirror this, that's what I need to do now, I shouldn't go back to the home tab and choose mirror from there. That's for the AutoCAD objects or generic objects. For sub-assemblies I have specific tools here, and I have part of them to mirror. So I'll ask me where do you want to mirror it to, I'll say mirror it to that. Okay, and we got this, our road. If I measure now our road from edge to edge, should be about 15 meters. And that's 15 meters, perfect. So this is the second component that we'll need to know. It's slightly different than the road design for rural roads, just different cross section. Okay, so as usual, we'll go back and circle it so we can keep it for later on. My next step is, as usual, to create the profiles. The first thing, to create a profile, I need to create the existing surface profile. So I'll create existing surface profile, and that will ask me for alignment 1. I'll say yes, based on the existing ground, and draw in the profile view. That's alignment 1. We'll call it profile 1, and I'll call it EG, so we know the difference between them. EG profile 1, and that's in the profile view. All of that all good, and just go and create that. This is our first existing ground profile. I'll do the same for the second alignment, and that will be for alignment 2. Again, I'll add it. I'll create profile 2. Keep an eye please on the naming. If you don't do the naming correctly, that will create huge problems for you. So please make sure that you keep an eye on the naming. So, and I'll add that here. So I've got profile 1, profile 2 for alignment 1 and alignment 2. Now for alignment 1, this is the existing ground profile. I need to create the proposed or design profile. As we know, to create a proposed or design profile, we usually go from the start to the end and we start creating areas of cut and fill. We shouldn't do that in our case here. We shouldn't do that in urban road designs. For one reason, I've got a few examples here. As you can tell, if I look at this road straight away, this road is not designed really with huge areas of cut and fill. In other words, let me show you examples of the highway. This is a small rural road design. You can see the areas of cut, the areas of fill, and that's permitted in a rural roads, because these roads are designed, keep in mind, there are two different type of roads for different purposes. These roads are designed to service two towns, for example, far away from each other. People usually they need to drive a long distance, so they need to get there in a reasonable time. So the speed limit on those is high, and to provide that safe drive, we have to create as flat as possible road. So we have to create a road with safety measures on it by creating the areas of cut and fill, so we can maintain the K values correctly, the horizontal radiuses, all of those that we discussed. Just to show you extreme examples, this is somewhere overseas. You can see sometimes even for the highways, which is the ultimate example of a rural road design or highway design, because we can't afford to create the highway to go above this mountain. It was here before they cut this mountain, to go above and below, because that will be, the cost factor is very high. The use of that road won't be as effective as by doing the proper work on it, by providing the areas of cut and fill. Obviously with maintaining reasonable approach there in terms of balancing the cut and fill and trying to find the best way to avoid as much topography as possible. Lots of other examples of those, as you can see. The ultimate example of that, guys, you can see on the highway between South Australia and Victoria, at the beginning of highway here on the edge of the it's just on Adelaide. You can see the highway, it's being cut in a excessive way within the mountains there to provide a smoother connection to the other side of the mountains, Adelaide Hills. So that is completely different, obviously, as we agreed, comparing to a urban road design. Let's have a just view of an urban area. The one thing you can tell easily from there, just by looking around, that the road design is really following the existing ground. As you can see, where is the existing ground? The road is trying to follow that as much as possible. Minimum areas of cut and fill. And usually, as you can tell from all the examples that you can see here, the houses will be built around this area. It will be slightly higher off the road. In other words, the road will be slightly lower than the existing surface, which will be making the paces for the proposed houses or the new houses. So if we have a quick look at these examples in different areas, as you can see, the road is slightly lower than the surrounding grounds. This is the main rule that we have about the profile, and this is what we should be creating there. So I would suggest that we create our center line of the road to be about 150 millimeter or 100 millimeter up to 200 millimeters. Let's go with 150, lower than the surrounding surface. So how to do that? If I'll try to trace this existing surface and draw a profile, we can do that. That will take very long time and will be not the easiest job to stay 150 millimeter, taking into account each one of those squares is 1 meter. So 150 millimeters roughly is that distance here. So you can go ahead and draw that, but we've got an easier way to do it. Semi-automated. The software will help us to create what we call the best fit profile. So to create the urban road profile, I'll go to profiles, profile creation tool. I won't choose it. I'll go to the one after, which is create best fit profile. Let's see what that tool does. Anyway, please keep following the information you're getting here from the software, okay, the instructions. So it's saying select a profile view, not a profile view. So if I select this profile, it's not going to work. I have to select the profile view. I'll say this is the profile view I want to work with, and it's asking me what's the input data that you want to create the best fit to it. In other words, what do I have as a base or benchmark so I can create the best fit to this? Do you have an AutoCAD polyline, for example, or feature lines, or any of those components? We don't have, other than the surface profile, and that's really what we want to create too. So it says there's only one profile there called existing surface 6. That's fine. Gave it a number. It's not an issue. So that's the profile that we have there. There's no other profiles anyway. Only one profile in that profile view. The maximum radius for the curve detection, so 1,000, which is, don't worry about this sitting here. The curve type parabola, we agreed for the vertical profiles. It's not a circular, it's parabola. And you want to draw the proposed profile above and below, or only above? Not, we want it to be above and below. It shouldn't be a problem. We'll talk about this in a minute, what we're going to do with it. Based on alignment 1, we'll call it proposed as usual. Proposed profile 1. And what type of the profile, or what style you want to give us this profile. We want it to be a design profile, not an existing ground profile. These two texts, I'll keep them now. Usually we don't keep them, but I'll keep them so you can see them. And this is the layer. I'll keep the same layer the software is choosing for, and I'll go OK. This tick is showing you how much the fit. So it shows you there's a great fit, almost, if you can look at it, almost identical. The blue line over the red line, it's a great fit we got there. If it was too hard to create a fit, so you start seeing here some variations on the report. Anyway, it's not useful to us. The software created for us a proposed profile that is matching exactly the existing surface. That's a good starting point, but that shouldn't be everything we want. So I'd start with, so I can modify this correctly, what I'll do, I'll show the labels. I'll show for the sag curves, add them. For the crest curve, I'll add them. And for the lines, I'm not going to show the slope 1 in 200 or 1 in 300 or 1 in 40. We show it as usual as a percentage, 1% or 2%. Apply and OK. So I've got those, and why did I show the labels? Just simply so I can see I've got a very small curve here with a K value that is very small. So usually those I'll be getting rid of them. The software did an extreme job to match them exactly to the existing ground surface, but I'll be doing some minor modification to remove these extra curves that I don't see the reason for them. What I'll do first, I'll go over the smaller ones, very small, remove them. That obviously will change my fit here, will make it deviate a bit from the existing profile. That's fine. So to do that, just all I have to do, just if I select the tool profile here, the new design profile, that will give me again the geometry editor. Let me close the tool palette first, because I don't need it anymore, and go back to tool space. Okay. So going back to this menu here, we just opened. I can straight away go to the panorama and have a quick look at those K values. I can see there's lots of K values are smaller than. So the second question, what is the K value? As we agreed, we don't have really major concerns here because we're designing an urban road in a suburban area, but I'll try to keep the minimum K value at least at 10 meters, at the value of 10. Okay. So before I've got all of those, that's great. I'll come back to this in a minute, but before I do that, what I'll do, I'll go around and just wherever I see the smaller one, very small one, first of all, I'll try to see if stretching those curves will improve our design. So that will keep my K value in a larger value. For example, that one there. This one here is kind of confined between two curves. It can't stretch too much, but still we got the right K value on it. I've got two small ones here next to each other. I would say first of all I'll get rid of this one here. For this one I think we can widen it, and I'm keeping an eye on my K value. For this one I need to remove it. I'll come back to it in a second. This one definitely we can make it larger. And those are good enough. I think I'll keep them for now. Okay, this one here, as long as I have the space to make that K value larger, why not? We can do it, and we maintain our fit to as close as possible to the existing surface. But if I do that for this one, if you look at it here, because it's sitting next to a curve here, it will limit me only to be stretched just here. As you can see, I can't stretch it anymore. So the easier way, just to remove it. All I need to do, remove that PVI, which is where the curve is. All I need to do, just click here, remove PVI, just click anywhere next to it, and that will remove that particular PVI. And then I'll go back and maybe adjust this curve to be a bit larger than what it was before. Now to check everything, that's why I said we'll go back to here. I'm looking at the K values here. I still have two K values, few of them are less than 10. What I'll do, the first thing, I'll try to change them from here before I go back and check on that. I've got a huge one here. Going back to this one, still, see, couldn't solve again because it could be confined next to another curve. That's fine, we'll go back to it. So this would be here. Let's see which one it is. Usually it's highlighted in red. It's some way halfway through. This is the one here. Okay, so for this one here, I need to shorten the curve next to it so I can stretch it manually, and that should increase the K value still at 7. If that's the case, what I'll need to do is just remove this in a minute. I will make it smaller, as small as possible, so I can remove it in a minute and increase this K value up to 10. Now I'll just close here. I'm looking at the K values, all of them higher than 10 other than this one. Go back and just click next to that, enter, and that's it. So what we got so far, if you notice, we've got best fit profile. All the K values, they meet our requirements. One last thing we need to keep an eye on, as we agreed, I need my surface of the road to be sitting lower than the existing surface, or the new road design lower than the existing surface. So I don't want it to be at the same level. So to do that, we can lower the entire profile automatically by just clicking on here, lower or raise a profile. Will ask me how much do you want to change the elevation. I say change it by negative 0.15 of a meter. That means 150 millimeters down. Enter, and that lowered it down by 150 millimeters, the entire road. That way I make sure I've got all the K values. I'm sitting below the existing ground, and that should comply with most of the, I've got an area, small area here, for example, where the road is slightly above the existing ground. That's fine, because we can't really create something that always below the existing ground. As you can see from here, there are some areas where the road slightly above the existing ground, you see a lot, and then that will create the road is higher, a small slope to the neighboring property. That's fine. I'll do the same now without giving too much comments. I'll do the same for the second profile, so I can do it quickly. Okay, one of the main things, I usually try to keep the curve slightly away from the beginning or the end of the road. We will talk about it later on, because usually the end and the beginning of the road, that's where we will have a intersection. So we usually do some minor adjustment around here. So I just try to keep it away, at least up to 5 meters away from the end or the beginning of the road. That's for the curves. You can't do too much adjustment on the curves, what we can do on the lines. Okay, all my K values, they comply, and I'm looking at it here. I've got a large portion of the road sitting below the existing ground. The fit wasn't that great here, so what I need to do now, I'll add points myself and add radiuses and curves for them. To do so, just click on your profile, and again geometry editor, the same point, the same next to the deleting a PVI, we can add a PVI. So I think I'll need one here, and I'll need maybe another one just here. That will add the PVI without the curve on it, but we need to add the curve, so we always add the free curve, free parabola curve. What does it mean free? That means the curve, it doesn't have any control, it's confined to the two tangents next to it, and that's what we want. We don't want a fixed curve that's fixed with value. We want it to be free and confined or controlled by the two tangents next to it. So I'll go to free curve, and will ask me again, follow the instructions, select the first entity. So I want, this is the blue one, is the first entity, and that's the second entity. Okay, sorry, that's the first, so I need the second one. Just keep click on the red one. I don't want to do that. This is the second one. Okay, sits exactly above it, so it makes it harder. Let me just move it a bit away. So going back, adding a free curve, sorry. So this is the first entity, and the second entity, and ask me what's the K value. I'll choose a 20, although we will have larger than that. Enter, and that's created the curve here. If I finish, I can continue with the other point, but just so I can show you, by clicking enter, that's it, that will finish that. Okay, and I can move it down now the way it was. I don't need it to be that high above, and that will make my K value anyway larger. For this point here, maybe I'll stretch it down somewhere here, and I'll create another curve, and the K value 20, enter, and that's created the curve between them. Again, if I make that curve slightly larger, try to create some just like that. Now I've got everything set. that's still sitting above. I don't want it to be sitting above. I would like to add another point here and curve these two entities and 20, enter. That's a bit better fit, so I can keep the road below the existing surface. That's all looking good. Just to make sure, I'll go back and check my K values for the last time. Geometry editor, and my K value, all of them larger than 10, that's fine. Okay, all good. So the last step I need to do, as we agreed, need to move it down by 150 millimeters. So geometry editor, move the entire profile. Ask me, do you want to move the entire all profile or some stations? I'll move it all. -0.5, enter, and that's moved down. Perfect. Now, as you notice, we always talked about if the profile not exactly on the existing ground profile at the beginning and then, that will create a problem. In fact, it's not about being exactly on it, it's about being exactly on this vertical line. It could be on it, could be above it, could be below it, as long as if you draw a vertical line here from this, if you choose it to be auto 100% vertical, that is sitting on it. So that will create a problem. Can you see that small space? When I moved it down, that will create a problem for us. I can either just draw a line here if I want it to stay on this height, because we want it to be on this height, and shift right click in point. That will work as long as it's vertically below and above it. Why? Because simply it's just that will create an area. What I had before, let me undo so I can understand why the issue will be created. What I had here, I've got an area of the alignment, which is, it does exist, that space here, whatever it is, could be very small space. It doesn't have any information about the profile. It has a gap here, so it can't read any information on the profile, and that will create that huge drop at the beginning or the end of your profile. If you see, when you look at your corridor, you see a large drop down. That means there's part of your alignment doesn't have any information of height, so it goes to 0. To avoid that, just make sure it's either sitting on this point or at a vertical line of that point. So I'll just make it sit here, because we'll need it to be slightly below for the intersection design. Shift right click on it. I'll do the same here. If I keep that small line, wouldn't hurt. Even if you can see it here, looks perfectly perfect. That's, if you zoom in, usually it's not. So I make sure, see there's a small gap there. Make sure I don't take chances, just make sure that you do it the right way. Make sure I draw a line, vertical line here, up to here, then go back, space that way, and go back, shift right click in point of this line, and that will fix to it. I can delete this line or keep it, wouldn't matter really. Okay, I have to check the same thing for the first profile. All of those you will learn them from experience after you have lots of problems with them, and then you decide to fix them initially without having any issues. Easier. So I'll keep it to here just to make sure I'll space the way. I'll do the same thing here. In point, line, in point. Perfect. That fixed it. delete. Right, so the last one component, which is there's no difference whatsoever between rural road and urban road, just to create a corridor. So this is the easier part of it. Just creating a corridor, basic corridor, alignment and profile, alignment 1 and proposed profile 1 with assembly 1 general, and target the existing surface. Go OK, and I'll reduce my frequency to 10 meters for urban road design. In fact, I'll reduce a bit later when we start creating the intersections a bit further to 1 meters around the intersection, but for now I'll keep them all at 10 meters and apply OK, rebuilding the corridor, and OK. So that didn't give me any errors. That means everything is fine here. And just to make sure about this, if I see this on 3D view, object viewer, as you can see, there's no drop. Do you remember what I was saying? If you had any issue with the profile, that would create a large drop at the beginning or the end of your corridor. Okay, I'll go back to create the corridor 2. Corridor 2, alignment 2, and proposed profile 2 with assembly 1 general, and all of that, all good, and OK. Again, just change the frequencies. OK, apply, and OK, done. So that will prepare you. The reason me doing this, guys, just to give you the starting point, how I got to the first video when you watch the videos on the intersection design. So if I go back here, by reaching this stage, you are ready to start on this video. Here will appear in a second. This video here, okay, for the intersection design. So in these two videos, I'll be designing the road intersections around 2 points of 3 videos actually. As you can see, I'll design this intersection and that intersection. So going back to our file here, I'll be designing this intersection here and that intersection, because what we currently have, as you can see, I've got 2 corridors sitting on top of each other, which is not, it shouldn't be the case. We design actual intersection there. This will give you the basis to, if you'd like, to create as many examples as you would like. You can create an alignment here, create an intersection here, an alignment there, intersection here. You've got endless examples to practice if you'd like to. Also, I've got another 2 videos here at the end to show you a slightly different method. I call it the manual method. In these 2 videos, I'll show you the slightly automated method from the software. This method here, the manual method, will be quicker as long as you do understand these steps that we're doing here. So you can watch those, and I advise to watch those definitely, especially this video. That will show you how to create the intersection slightly different way. It could be easier and quicker for you. Alright guys, this is the end of this video. So I save your file here so you can use it for those exercises, so you can submit at the end of this practical. I'll add a component here for the submission design. We do have that, should be submission portal, for example, for intersection design. Yeah. Alright, I'll leave you with it. If you have any questions, send some comments on Teams, and we'll get back to you as quick as possible. By the way, I'm at TAFE every Wednesday until the end of this semester, until 8:30 in the evening. So I'll be there from 10 o'clock in the morning until 8:30. I usually have breaks around 1:30 and 5 o'clock, 1 to 1:30, 5 to 5:30, or after 8, or during the lectures. If you would like to have a question, you want to bring your laptop, come in, and we'll find a time to answer your questions. All right, thank you guys. Bye for now.